So hi, welcome to the playlist where we are going to solve DSA problem which needs queue. Now today's problem is that we need to implement the queue using the stack. We need to support all queue operation, push, pop, peek, empty, but we can only use stack operation. Stacks gives us LIFO, queue gives us FIFO, that is first in first out. So how do we flip the order? Okay, so in the question, this is basically a lead code question in which they are not asking us to use only one stack. They are saying use stacks. So we can use two stacks to implement a queue, right? Now, if I talk about the queue, queue follows FIFO as we already know. So this is a queue, right? In which the first one who is coming in will be the first one should go out of it. Okay. Now we need to implement it using a stack. Now the thing is that if this was a stack, okay, the last one who is coming in will be the first one should be going out. Okay, so basically it's a reverse order now. So how do we implement it? See, here I will be taking the help of two stack. Okay, in and out. Now when I want to push any element, it will be pushed on the in stack, and when I need to pop out or I need to find a peak, out will be used. Okay, so let's take one example. 2 has to be pushed, so push here, then 3 push here, 4 push here, 5 push here, and let's take one more, 6 push here. Now I need to pop it. Okay, now see guys, since it is a stack, so I'm saying pop, but when it comes to queue, the word is dequeue, not pop. Okay, now when we want to dequeue it, okay, this was the first element that came in, right? So this will be the first one should go out, not 6. So what we need to do, so that 2 should be removed, not 6. Okay, see, here I will check if the out stack is empty or not. If the out stack is empty, I will simply store all the elements inside this. Okay, so I will be start popping each element one by one, and I will be storing it over here. So this 6 will be popped and it will be stored or pushed over here. Then 5, then 4, then 3, and then 2. Okay, now here you can see that 2 is at the top. Okay, now I'll simply call a pop function for the out, so it will pop this 2. I hope you got it. Now see, 2 is not there, right? And I need to get the peak. The peak is 3, right? So I'll call peak. Here also it will happen in the same way. First it will check whether the out stack is empty or not. First it will check the out stack is empty or not. If out stack is not empty, it will simply return what is there at the top. Okay, now let's say again I want to store some element or push some element. So 7, so I'll push it over here. 8, I'll push it over here. 9, I'll push it over here. Okay, now again let's see if I want to delete it. So 2 I have deleted, 3 has to be deleted. Okay, so I'll simply check whether in the out stack whether these elements are there. If it is there, I'll simply pop this, right? I hope you got it. Now what happens? What happens if the stack is empty? Let's see if I deleted this one, this one, this one, as well as this one. Okay, so all the things has been deleted. Now when I want to pop it again, 7 has to be deleted, but here we can see that 7 is present at the bottom, right? This is 9. Okay, so again I need to pop all the element one by one and push it over here. Okay, so pop 9 and push it over here, pop 8 and push it over here, pop 7 and push it over here. Now we can see that 7 is there at the top. Okay, so we can simply pop it. Okay, now I believe you got it. Now we have understood push, we have understood pop, also we have understood peak. Now let's talk about pseudocode. So the push operation is very simple. Void push interval. Okay, it's very simple. Just do in dot push. Okay, now what to do when it comes to pop? So since we are popping it, after popping we need to return that value, right? So int pop. Okay, now see, over here we have used stack. So when I want to pop it, okay, the top of the stack will be deleted, right? But I don't want that. I want to delete the first element which has entered. So first I'll check if the int stack is empty or not. Okay, so I'll basically make a function move if necessary. Okay, I'll call this function first. Okay, now what this function will do, it will check first that whether the out stack is empty or not. Okay, if the out stack is empty, it will pop all the elements one by one from here and push it over here. Okay, and after that I need to pop the element which is present at the top on the out. Okay, so return out dot pop. Don't worry, we will discuss about this function move if necessary. Okay, now let's talk about peek as well. So int peek. This function is also very similar. Move, first we will call move if necessary function. Okay, and after that we will return out dot peek. Okay, now let's talk about move if necessary. So void move if necessary. Now first over here we will check whether the out stack is empty or not. If out dot is empty, if it is empty, then we are going to pop all the elements one by one from the in stack and push it in the out. So while in dot is empty, and here I need to put a not. Unless and until it is not empty, it will try to pop all the elements and push it in the out stack. So out dot push in the brackets in dot pop. That's it. We are done for this function. Okay. Now the question arises, Samir, that what if the out is not empty? If the out is not empty, if it is not empty, we will not enter in this case, and we can simply return out dot pop or out dot peek. Okay, because this stack is not empty. This stack is not empty. So why we need to push the elements over here from here to here, right? We can simply return 7 because it is at the top of the stack, and 7 basically means that among this 7 came first. So this has to be removed first, right? Now the last question, that how to check or what to do that whether it is empty or not. So it's very simple. Int, or let's have a boolean empty. Just return in dot is empty and out dot is empty. If both are empty, then we can conclude that the stack is empty. If this is empty, it will return true. If this is also empty, it will return true. So true and true will give me true. So if the elements are not there, this function will give me true, otherwise false. Okay, so I believe you got this solution. Okay, if you didn't, you can try running it by yourself. If this lecture helped you understand the concept better, make sure to like the video, share it with others who are learning, and don't forget to subscribe for more easy DSA explanation. That's it from my side. I'll see you in the next lecture. Till then, keep practicing.